All right, so in this video, we're going to talk about some of the basic assumptions of projectile motion. So one of the first things we have to remember is that as projectiles move through the air, they follow a parabolic path or a trajectory. One of our big assumptions here is that in the x direction or the horizontal direction, velocity will always be constant, so acceleration is 0. And in the y direction, an object will always move under the influence of acceleration due to gravity, which we learned as little g, or negative 9.8 meters per second squared. So to give you a formal definition of a projectile, we can call a projectile any object that's launched into space without motive power of its own. So in other words, it's not equipped with a motor or an engine or something that would cause it to deviate from that parabolic path. So we'll always neglect air resistance in our problem solving, which means that the only force acting on a projectile is gravity, which causes its path to deviate from a straight line. Much like this picture over here, we have a partial parabolic path. Since there's no acceleration in the x direction, we'll say that the projectile has a constant horizontal velocity and a vertical velocity that changes uniformly under the influence of acceleration due to gravity. So as you can see in this picture over here, the velocity in x stays constant the whole time, that vx, but that vy is initially large because the object's moving up. That gets smaller, and then the vy increases as it heads towards the ground. So for all of our problems, we'll always assume that there's no air resistance, but it's worth knowing that air resistance causes objects to fall short of their predicted path. For a lot of the labs we do in class, the impact of air resistance will be pretty negligible, but over a much larger distance, so for someone like hitting a golf ball, the effect of air resistance will be a little bit more pronounced. So there'll be a good amount of math involved in these types of problems. Before we talk about the math, though, we're going to look at 3 different types of projectile motion. So in our type 1 projectiles, we're going to have an object that's launched horizontally. So write that down as your key phrase to look for a type 1 problem. An object is launched horizontally. For a type 2 projectile, we have an object that's launched at some angle, and it lands at the same height that it started at. And then finally, for a type 3 projectile, we have an object that is launched at an angle and lands at a different height than where it started. So our projectile motion unit will be split up, where we'll do some practice problems with type 1, we'll do a type 1 lab, then we'll take a quiz, we'll repeat for type 2, and then we'll finally incorporate type 3. So we'll see that there's lots of variables involved here, but there's no new equations compared to what we've been doing so far this year. So we'll start by looking at the x direction, where these are all the different possible variables we could have. We could have a distance, we could have a v1, which is just another way to write initial velocity. We could have a v2, another way to write final velocity, which I usually write as vf. We could have time, and we could have acceleration. But we already said that in the x direction, we have constant velocity, which means that initial velocity is equal to final velocity. Also means that acceleration is 0. So the only 3 variables we can have in x are displacement in x, velocity in x, and time. That also means the only equation we can use in the x direction is the first equation on our equation sheet, where velocity is equal to distance over time. In the y direction, however, we could have all 5 of these variables at play. We could have a distance in y. We could have an initial velocity in y. We could have a final velocity in y. We could have a time and an acceleration. So a lot of this will make a lot more sense as we start to solve problems, but a couple of things that are worth knowing for now is the distance an object rises or falls, we'll call that dy, displacement in the y direction. For initial velocity in y, I'll usually write this as vyi. For final velocity in y, on the way up, it comes to a stop for a split second, so the velocity in y at the top is 0. We could calculate the amount of time for an object to go up, and acceleration will always be negative 9.8. On the way down, we can have a similar set of variables. One thing that's worth knowing for now is that initial velocity in y will be 0 if an object is dropped or if it's launched horizontally, like we'll see in our type 1 problems. So this part of the unit gets a little bit subscript heavy. Depending on what resource you're looking at, you might see different subscripts used to indicate initial velocity. So sometimes they write them like this, v with a 0. This is pronounced v naught, and that just tells me initial launch speed. Often we'll also include variables to differentiate between the x and the y directions. So here's a good example of a type 1 problem. So we have a guy throwing a ball off of his 5th floor balcony, and it looks like he's throwing that ball horizontally. You'll notice that the initial velocity in y is 0, but as time goes by, the ball speeds up in the y direction. The x velocity, though, so they're calling that Vx naught, stays the same until the moment the ball hits the ground. This picture over here on the right is showing us that the x and y motion is independent of each other. So if you were to drop a ball or launch one horizontally, they would both actually hit the ground at the same time. And when I'm back in class, we'll see a demo to prove this idea. So in terms of solving projectile motion problems, a good strategy is going to be separating everything into the horizontal and vertical directions. So we'll make a 2-column table, one column labeled horizontal, the other one labeled vertical. The only thing related on both sides of this table is going to be time. How we approach relating time on both sides of the table will be different depending on whether we're dealing with type 1, type 2, or type 3 projectile motion. So in terms of equations that you can use, in the horizontal direction, we have constant velocity. Acceleration is 0. The only equation you can use is distance is equal to velocity times time, which is just velocity equals distance over time rewritten. In the vertical direction, there is acceleration due to gravity, so we can use any of the other equations we had for our gravity unit. Really, those would be equations 2 through 5 on your equation sheet. All right, so in the next video, we'll take a look at a couple of type 1 problems worked out. Thanks for watching.